Okay, so last time we actually discussed that the measurements actually involve two things, no? One is the apparent or the approximate weight or volume of the substance, and there's also this discrepancy, which can either be a deficiency or an excess in the measurement, okay? And that is what we consider as the error in the measurement. Okay. Now, also remember from our last discussion, I don't know if we actually made it to this part of the discussion, but anyways, remember also that whenever you read the measurements using your graduated cylinder or any of your measuring glassware, in the laboratory, there is what we call a reading error. Okay. And that error is due to the apparent differences in the way that we see the graduations in the glassware. Okay. Ayan. So it is often mentioned, and it is also required, as in the United States Pharmacopoeia, to always read measurements at an eye level, okay? And the reason for this is to minimize what we call as your parallax error. And hold on a moment. Ah, wait. And so we read measurements using our glassware at an eye level to, oops, hold on, to minimize what we call as your parallax error. Okay. And so, and so this parallax error is an error that is due to inappropriate reading of the measurements. Okay. If you, for example, measured or read the measurement in your pipette at a position that is lower than your eye level, okay, then you might be reading it na higher than it usually is. Okay. Now, when you read it naman at a level where it is higher and than your eye level, and then the measurement can actually be lower than it actually is. Okay, so you have to read measurements always at an eye level, okay, like this. And so sometimes in the laboratory, we see students who are kneeling down, okay, or yung iba naman, they are standing on top of the seats, okay, only to be able to read measurements, especially in burettes, okay, and so you'll get to experience that pretty much very soon, okay. Now, even if you read measurements at an eye level, there can also be a reading error, okay. And so this is the reading error as described using the three different measuring glassware. Okay. Now, the larger the diameter of the glassware, okay, the larger will be the volume error that corresponds to that same, okay, reading error. Okay, so meaning to say the same height of the reading error and can lead to a greater error in volume measurement as the diameter of the glassware increases. Okay? And that's why we say that when you want to accurately measure liquids, you must use a narrow gauge instrument, such as your pipette or your burette. Okay? In the United States Pharmacopoeia, if it is mentioned to accurately measure something, okay, and you are always asked to measure using only either pipette, the appropriate pipette, okay, the appropriate capacity of the pipette, or burette, okay. You should never use a graduated cylinder, or worse, a beaker, to accurately measure liquids. Okay, and so take that note. Put that in your mind always, because that is a very important technique, okay, for you to remember in your next courses, no, in your subsequent courses. And now, as we mentioned before, there are two things that are important in our measurements. The actual measurement, which is an approximate value, okay, so the approximate measurement, or the apparent weight or volume of the substance. And there is also the excess, or the deficiency, or any discrepancies in the measurement, which may be caused by errors by the operator or by the instrument itself. And that's what we call as the error. Okay. That's why whenever we express measurements, it should always have a tolerance value, okay? And so meron tayong nilalagay na plus or minus, ayan. And we put here the error, ayan, of the measurement. So the approximate value is written here, and the error is written here, okay? And most of the time, the error is given to us by the instrument itself. They are most commonly written in this portion of the glassware. Okay, and so you can always find that in your glassware. Now, in your balances, of course, we also have a similar thing, okay, which you can find at the back of the analytical balance. Okay, so the next topic that we will be discussing will be an application of the measurement of the determination of the percentage of error. By the way, no, let us review what percentage of error is. Okay, and so remember that we mentioned last time, percentage of error, or percentage error, is equal to the maximum potential error, or the error. Okay, divided by the quantity that is desired times 100. Okay. Now, in my case, no, in my discussions, I will always write the percentage, okay, as a unit. Okay, so take note of that. In my discussions, I will always be putting the percentage as a unit, okay, but it is never used in calculations, okay. Meaning to say, whenever you input the value 100, in the calculator, do not press the percentage symbol. Okay, otherwise 100% will simply be equivalent to 1. Okay, and so I think that's the problem with the previous batches. Okay, and which I just very recently noticed. Okay, whenever they computed percentage values. Okay, now, why do I do that? Because I want to show that whenever you cancel units, okay, what will be left will be the percentage symbol. Okay, and so that's why, again, no, as a disclaimer, this is a unit which is not ever included in calculations. Okay, so the percentage of error is equal to the error, ayan, or the maximum potential error, also known as the sensitivity requirement, divided by the quantity that is desired times 100. Okay, and so we have the percentage of error. Now, we can also determine the smallest quantity that is measurable in your balance using this formula. Okay, and so later on we'll discuss the least quantity method of weighing, and we can actually determine the smallest quantity based on the percentage of error that is indicated in the instrument and its maximum potential error or sensitivity requirement. Okay. And so the smallest quantity is actually derived from this formula. Okay. We simply transfer this to here and percentage error to here. Okay. And so the formula is basically the sensitivity requirement or the error or the maximum potential error and divided by the percentage of error times 100%. Okay? Now, you will understand why I always put the percentage here kasi um, the percentage of error will have a unit that is percentage and we cancel the percent. Okay? And what will be left is whatever unit is in your maximum potential error. I think there is a chat. Ayan, hold on. Okay. Noted. Thank you for that, Miss Amy. Ayan. Okay, so please tell her that she can always request for the recording of this discussion. Yeah. Okay, and so I hope you still remember these two formulas. Okay, and because we will be using them in the following discussions, no, particularly in the Aliquot method of measuring and weighing, and in the least quantity method of weighing. Okay, yeah. So what is this Aliquot method of weighing and measuring? Okay, so let me describe this to you. This is actually a very simple technique. Okay, of measuring or weighing substances which are lower, okay, or has a volume or a weight that is lower than the lowest quantity that is measurable in the instrument that you have. Okay, and so what am I talking about? Okay, so basically it's this. Now let us say that you have a balance. Okay, you have a balance with a sensitivity requirement of, let's say, 6 milligrams. Okay, ayan. Now, what is the meaning of this 6 milligrams? No, it means that it is able to distinguish weights, okay, which have a difference of 6 milligrams and above. Okay? Ayan. So remember that that is the meaning of that. Okay? Ayan. So if you are already tackling botany, okay, perhaps you can imagine this as similar to your resolution. Okay? It's the ability for you to distinguish two closely spaced objects. Okay? Diba? Sa microscopy in botany. Okay? I know that you love botany because I always read in your Twitter feeds. Okay? That there's this requirement again from botany, and that's the first thing that you have to do. Ayan, so you are leaving again pharmaceutical calculations behind. Ayan, but but that's okay. Ayan, so so I hope you remember that. The resolution, it is the ability of the microscope to be able to distinguish two closely spaced units or objects, right? Ayan. So if you imagine, if I would relate, okay, our discussion of pharmaceutical calculations to your botany, resolution is similar to our maximum potential error or the error, okay? Ayan. So no shade about that, no? Ayan. Um, so let's say when you see that an error is 6 milligrams in a balance, it means na the balance is able to distinguish, okay, between weights, okay, whose difference is 6 milligrams and above, okay. Below 6 milligrams, it will not be able to distinguish that, and also, if the measurements of two substances are less than 6 milligrams, then their weights are basically the same. Okay, yan. So yun lang yung ibig natin sabihin dyan. So let me give you an example. And let's say you are trying to weigh 10.00 on 50, you want to weigh 10 grams of a substance. Okay, and so sabi doon sa manual ninyo, you have to weigh 10.0 accurately, no? You have to weigh accurately 10.0 grams of a substance. Okay, most of the time, students are waiting for the balance to be equal to 10 10.0000 grams, no? I don't know what it means to them, no? Mukhang ano, mukha siyang crowning glory, no? If you're able to weigh something exactly, ayan, to the last digit, okay? But it is not necessary, okay? And you have to know the error or the maximum potential error of the measurement, okay? And so let us say you would like to weigh 10, accurately 10.000 grams of a substance or 10.00 grams of a substance, and the weight that you got ay 10.0050 grams, okay? Yeah, now let's say that the instrument has an error of 6 milligrams. Okay. What is 6 milligrams equal to in grams? Okay. Yan. So in grams, 6 milligrams is basically point zero. Ayan. So magbibilang tayo. 1, 2, 3. Okay. 0.006 gram. Okay. So meaning to say, this measurement, 10.0050 gram, is actually the same as 10.0000 gram in the instrument that you are using, okay? Because the limit of accuracy of the instrument is 6 milligrams, okay? Ayan, so it will be futile for you to try to get a value that is 00 for these last two decimal places, okay? So please don't do that, no? Otherwise, you're just wasting your time, no? In the balance, okay? So I hope I have made that pretty clear, okay, about the error. Now, also remember that, hold on. Also remember that the smaller the weight of the substance that you want to weigh, okay, the greater will be the effect of the maximum potential error, okay? So we know that the maximum potential error is a constant, okay? But if let's say mas mababa yung quantity that is desired, if the quantity desired is lower, okay, and then the percentage of error also increases. Okay, it follows that when you are trying to weigh a very small quantity, okay, the percentage of error increases, okay, for a given maximum potential error. Okay, and it can be seen in these formulas, right? And so what it means is that when an instrument has a given maximum potential error like this, okay, you would like to know what is the smallest quantity weighable in that instrument to minimize or to not exceed the percentage of error, okay, that you would like to have in your measurement. Okay, so that is what we are going to do in this discussion. Okay, yeah, so let us say that that instrument with a maximum potential error of 6 milligrams, you would like to have no a percentage of error that is not more than 5%. Okay, so you don't want your measurements, okay, to exceed 5%, okay, na percentage of error. Okay, you would like to now determine the smallest quantity that can be determined using your instrument. Okay, and that can be computed like this. No? So 6 milligrams divided by 5%, which is our percentage of error, times 100%. Again, we don't use the percentage here because the percentage there and the percentages there are simply our units. Okay? Yeah, so 100 divided by 5 is 20 times 6 is hold on, 120 milligrams. Okay, yan, napaisip ako ng konti doon. Okay, so the smallest quantity that is weighable in your instrument, therefore, is equal to 120 milligrams. What does it mean? Um, you cannot weigh, okay, a substance whose weight is smaller than 120 milligrams. Okay, yeah. So let's say that the maximum potential error is 6 milligrams, and if you don't like to exceed the percentage of error, that is 5%. Okay, you cannot weigh, okay, 10 milligrams or let's say 8 milligrams, ayan, basta mga ganong amount, of a substance because 10 milligrams or 8 milligrams are much, much less than 120 milligrams. And that would mean na the percentage of error will increase if you weigh that amount of the substance in your balance. Okay, so I hope you understood that part in this discussion, right? And so if you have questions, just do not hesitate to post your questions in the chat box or raise your hand, no, so I may see. And so in that particular example, no, let us say that you would like to weigh, okay? You would like to weigh 5 milligrams, okay? You would like to weigh 5 milligrams of the drug, okay? Is it possible for you to weigh 5 milligrams in a balance with a sensitivity requirement of 6% and you don't like to exceed um, an error of 5%, okay? Well, from our discussion, we know that the smallest quantity required or the smallest quantity that is weighable in the instrument is 120 milligrams, and 5 milligrams is so much smaller than that. Okay, so ibig sabihin, meaning to say, 5 milligrams cannot be weighed in the balance. Okay, yeah, so what we need to do is we need to amplify or to increase the amount of the substance that you will weigh in your balance. And the only way that we can do that is by putting a diluent. Okay? A diluent is an inert ingredient that you can put, okay, that you can mix together with the drug, okay? It does not affect the drug, okay? But it increases the bulkiness, okay, of the drug powder. Okay? Ayan. So, in pharmaceutical terminology, it is the same as an excipient. Okay? Ayan. So, for example, your tablets contain excipients, okay, which are inert ingredients which are added to the drug. Okay? But this time, this is much simple. No, usually it's just either lactose or talc, okay, which are added to the drug just simply to increase the bulkiness, okay, of the powder for you to be able to weigh the drug. Okay? Ayan. Now, the problem is when you put the diluent, okay, based doon sa kanyang pangalan, okay, the drug will be diluted. Okay? Ayan. So, liliit yung kanyang amount. Okay? Yung concentration niya or its potency. Okay? Ayan. So, in order for us, okay, to still make use of a diluent, you must increase now the amount of the drug that you will weigh. Okay? Ayan. So, lalakihan mo yung amount ng drug that you will weigh. Instead of only weighing 5 milligrams of the drug, you will weigh, no, a higher than 5 milligrams na amount. Okay? And you will dilute it with an inert ingredient, and you will only take a fraction of the powder, and that is what we call as the aliquot. Okay? Ayan. So the aliquot is simply the fraction or the portion of the powder. Okay? Ayan. Now, what are some things that really important in the aliquot method of weighing and measuring? Take note that the amount of the drug that you will weigh should be equal to or greater than the smallest quantity that is weighable in the balance. Okay? Ayan. So, dapat daw, yung weight ng drug that you will initially weigh should be greater than or equal to the smallest quantity weighable in the balance. Okay? Another thing is that the amount of the diluent that you will add should also exceed the smallest quantity weighable in the balance. Okay? For obvious reasons. Okay? Kasi if you decide to weigh, okay, either the drug or the diluent na smaller dun sa smallest quantity required, the percentage error increases. Okay? And finally, the third thing that you have to remember is that the aliquot, okay, or the fraction of the powder should have a weight, okay, that is equal to or greater than the smallest quantity that is required in the balance. Okay, so those are the things that you have to keep in mind in the Aliquot method of weighing and measuring. Okay, so let us now continue. No, ayan. So still, in our problem, the sensitivity requirement is 6 milligrams, and we don't like to exceed a maximum error of 5%. Okay, so the smallest quantity weighable in the balance is 120 milligrams. Okay, now what you can do is you can divide 120 by 5. Okay, that is plausible. Okay, and so pwede nyo siyang gawin. So 120 divided by 5 is 24. Okay? So you can use a factor that is 24 or higher. Okay? Now in the textbook, I think iba yung sensitivity requirement and percentage error dito. But still, no, it applies, no? It doesn't matter. This one is an arbitrary value. Okay? Ayan. So the multiple or the factor is an arbitrary value. Okay? So normally what we do here is that you simply divide the smallest quantity, okay, um, weighable in the balance by the amount of the drug that you need to measure. Okay? So if we got 24, ayan, ibig sabihin, you can use a factor that is 24 and above. Okay? Let us just arbitrarily choose 25. Okay? Ayan, so pinili natin yung 25. Ayan, so the weight of the drug that you will initially weigh is 125 milligrams. Okay, so that's the quantity of the drug that we will weigh. Okay, and then what's the next thing that you will do? Okay, ayan, so yung next na part ay medyo tricky, no? Ayan, remember the third thing that I mentioned. Okay, so remember tatlo yung sinabi ko, the three weights which should be equal to or greater than the smallest quantity um, weighable in the balance are the drug, the diluent, and the fraction of the mixture. Okay? Ayan. Now let's say that you want to weigh in the end, no, a 120 milligram aliquot of the drug. Okay? So gusto mo mag-weigh ng 120 milligram aliquot of the drug. Okay? So what you can do is you can multiply this by 25. Okay? So 120 times 25. Saan ang galing yung 25? The 25 comes from the factor or the multiple. Okay? So 120 milligrams, yun yung gusto mong i-weigh na aliquot, okay? Times 25, the factor that you have decided upon in step 1, it's equal to 3,000. Okay? So anong ibig sabihin nun? That is the weight of the mixture, okay? That will give you upon apportioning into 25 fractions, okay? 120 milligrams of a mixture. Okay? Ayan, so yun yung ibig sabihin nun. Now, to determine the amount of the diluent, you simply subtract the 125 milligrams of the drug from 3,000 milligrams of the mixture. And that will be equal to 2,875 milligrams. So that is the weight of the diluent that you will add to the drug. So 125 plus 2,875 will give you 3,000 milligrams of the mixture, which is basically this. Okay? Next is we will only take a portion of the mixture which will contain 5 milligrams of the drug. Okay? So remember, ang gusto mo lang talaga in this at the start is to weigh 5 milligrams of the drug. Okay? So you would like to determine now the amount, okay, the amount of the mixture that will give you 5 milligrams of the drug. Okay? Now, remember that what we did is we multiplied 120 milligrams by 25. Okay? So by multiplying 120 milligrams by 25, we got 3,000. So ibig sabihin, yung 120 milligrams, yan na yung fraction that you will take, okay, which will contain 5 milligrams of the drug. Now, just to show that this is basically ratio and proportion, okay? Remember that in the 3,000 milligrams of the mixture, okay, so this is 3,000 milligrams of the mixture, you added 125 milligrams of the drug. Okay, now if you would like to get 5 milligrams of the drug from the mixture, okay, what will be the amount of the mixture? Okay, take note na when I did the ratio and proportion, yung nasa numerator ay yung drug and yung nasa denominator ay yung mixture. Okay? Ayan. So, we have this ratio and proportion. Again, in the 3,000 milligrams of the mixture, you actually place there 125 milligrams of the drug. Now, for you to get 5 milligrams of the drug in the mixture, what is the value X or the weight of the mixture? Okay. Um, what will be the equivalent weight no, of the mixture? Okay. Ayan, correct. Ayan, so thank you for that answer, Mr. Colico, no? Ayan. So, transpose lang natin, no, yung mga values. Okay? So, we will transpose x over here, okay? And then 3,000 over there and 125 over there, okay? Ayan, so what we have is x equals 3,000 milligrams times 5 milligrams divided by 125 milligrams. So we cancel milligrams. Okay, so we get 120 milligrams. Okay, so that's how we perform the Aliquot method of weighing and measuring. Okay, yeah. So again, this factor is a it is an arbitrary value. Okay, you can assign whatever you like here. Okay, yan. So suppose gusto mong gawin siyang 30. Okay, yan, gusto mong gawing 30 yung factor, and di okay lang, no? Yan, so wala namang problem. So 30 times 5, that is 150 milligrams. Oo nga naman, it's easier to weigh 150 milligrams compared sa 125 milligrams. Okay, next is what if I want to weigh 150 milligrams then of the um of the I also want to weigh 150 milligrams of the powder in the end. Let me just erase some of the stuff that are here. Ayan, para mas malinaw, no? Remember na the smallest quantity weighable in our balance is still 120 milligrams, right? And so I will just show you another computation, okay? Another way of doing this with different values, and but still acceptable. Yan. Okay. So let's say, no, you want to use, instead of 25 as a factor, you want to use 30, okay, as a factor. Because when you multiply 30 by 5, it's equal to 150 milligrams. Yes, it's easier to weigh 150 milligrams compared to 125 milligrams, right? And kunwari din, naisip mo na instead of weighing the least quantity or the smallest amount weighable in the balance, okay, you would like to weigh 150 rin, okay? 150 milligrams then of the mixture in the end. Okay? Yan. So, kunwari, yan yung mga gusto mong gawin. Okay? Now, what we will do is this. Okay? What you can do is you can actually multiply this by 30 as well. Okay? And this will be equivalent to, ayan, 150 times 30. And this will be equal to 4,500 milligrams or 4.5 grams. Okay? So, dapat daw yung weight of the mixture mo is 4,500 milligrams. Okay? So, what will be the amount of your diluent? The amount of your diluent will be 4,500 milligrams minus 150 milligrams. So, this will be equal to 4,350 milligrams. Okay? Is this still weighable in the balance? Yes, because the least weighable quantity is 120 milligrams, right? Ayan, so you will now mix 4,350 milligrams of the diluent with 150 milligrams of the drug powder, which will give you 4,500 milligrams of the drug. Okay. Now, for you to be able to determine the weight of the aliquot, although alam nyo na yan, that should be equal to 150 milligrams because you have already set it, right? Yan. But just to show you na it's doable, ayan, what you can do is this. Okay, so you know that in the 4,500 milligram of the mixture, you have 150 milligrams of the drug. Okay, now if you would like to weigh 5 milligrams of the drug, okay, what will be the amount X of the mixture that you need to get from the mixture or from the bulk powder? Okay, yan. So what we'll do is simply transpose. Okay, so 4,500 times 5 divided by 150, that will be equal to 150 milligrams. Okay? Yeah, so that's how Aliquot method of weighing and measuring works. What if, no, another example, what if ibahin na naman natin, no? And let's say, and so I just want to show that there are multiple ways of actually solving this problem. Okay? Ayan. So don't mind na lang the next slides kasi anyways ito na yon. Okay? So let's say na you would like to again arbitrarily assign lang, no? The amount of the mixture. Okay? So kunwari lang, no, on top of your head, you just want to weigh 5 grams of the mixture. Okay? You just want to have 5,000 milligrams of the powder. So take note, I did not, okay, even consider the amount of the aliquot that I need, okay, to weigh in the end. Okay, so it's just on top of my head. I want to have 5,000 milligrams of the mixture. Okay, yun lang, no, naisip ko lang. And then I just used a factor of 30 because I know na my balance can weigh 120 milligrams and above, okay, of the drug powder. Okay? So, ibig sabihin nun, it's 24 times um, 5 milligrams of the product or higher. Okay? So, 30 as a factor is a doable one. Okay? So, 150 milligrams yung aking amount of the drug. Okay? Now, if I would like to weigh 5,000 milligrams of the mixture, okay, then what will be the amount of the aliquot? So, it's simply 5,000 milligrams minus 150 milligrams, and this will be equal to 4,850 milligrams of the diluent. Okay, so ibig sabihin, you will add 4,850 milligrams of the powder to 150 milligrams of the drug to produce 5,000 milligrams of the mixture. The next question is, what will be this amount? What will be the amount of aliquot that you will weigh? So we will again do ratio and proportion. Okay. So I know that in my 5,000 milligrams na mixture, I have here 150 milligrams of the drug. Okay. Now, if I would like to weigh 5 milligrams of the drug, what will be the amount of the mixture that will contain 5 milligrams of the drug? Okay. So what I will do is simply ratio and proportion. So for 5,000 times 5 divided by 150. So the answer is medyo pangit lang, 166.67 milligrams. Okay. Yan. So, hindi lang masyado maganda. No? So, about 167 milligrams of the aliquot will be weighed. Okay? Now, 167 milligrams is still greater than 120 milligrams, which is uh, the limit of our balance to not exceed a percentage of error that is 5%. Okay? Ayan. So, I think I am already seeing some questions in the chat box. Ayan, hold on. Ayan, so thank you for those answers, no? So I hope I have made this clear, no, na there are a lot of variations here, no? You can change a lot of things, no, in the aliquot method of weighing and measuring. It's up to you, no? It doesn't have to be the same all throughout, no? Ayan, as long as it's logical, ayan, so it's still okay, okay? Now, if you would like to know naman how much of the diluent are there in the mixture that you will weigh, you simply subtract the amount of the drug that is present there, no? Ayan. So for example, in this example, if you weigh 167 milligrams of the mixture, and it will contain 5 milligrams of the drug, the rest will be the diluent, okay? So the diluent will be equivalent to 162 milligrams, okay? Ayan. So that's how you do it, no? For the Aliquot method of weighing and measuring. And so let's have an example here. Ayan. So a torsion balance has a sensitivity requirement of 6.5 milligrams. Explain how you would weigh 15 milligrams of atropine sulfate with an accuracy of 5% using lactose as a diluent. Okay. So remember the steps that we need to do. So the first thing that you will do is you will determine the smallest quantity that is weighable. Okay. And the smallest quantity is equal to 6.5 milligrams divided by 5% times 100%. Again, the percent is a unit, okay, in my calculations. So 6.5 times 20 is equal to 130 milligrams. So the smallest quantity that is weighable in our balance is 130 milligrams, okay? Let's say I want to weigh, no? I want to weigh 150 milligrams of atropine sulfate. Is it okay to weigh 150 milligrams of atropine sulfate? If your answer is yes, no, ibig you are correct, no? Kasi 150 milligrams ay greater than 130 milligrams. So we'll do it. Okay, yeah. So we'll set, okay, the weight of atropine sulfate to be 150 milligrams. Okay. Now let's say I want to weigh ano pa ba? Gano'n din, 150 milligrams pa rin, no? I also want to weigh 150 milligrams, 150 milligrams, wait, 'di maganda. Gawa tayo ng mas maganda. Let's say I want to weigh, okay, 100 or sige gawin nating iba. I want to weigh 260, 'yan, milligrams of the Aliquot in the end. Okay, ayan. So these are the arbitrary values that I just set. Okay? Walang ano to, walang basis. Okay? Except that gusto ko lang ng whole numbers. Ayan. So I will weigh 150 milligrams of atropine sulfate. Okay? And then I want to weigh two, 200, 260 milligrams of the Aliquot in the end. Okay? Ayan. So yan yung mga gagawin ko. Okay? Ayan. So what will be the amount of the powder that I will weigh? So let's say na I want to weigh ano ba maganda? 5,200 milligrams of the mixture. Okay? Ayan, sinet ko rin yan. 5,200 milligrams of the mixture. Okay? Ayan, so 5,200 milligrams of the mixture minus 150 milligrams of atropine sulfate will be equal to, ayan, 5,200 minus 150 milligrams. This will be equal to 5,050 milligrams of the diluent. Okay. Next is I want to determine now, okay, if I would like to measure 6.5 milligrams of atropine sulfate, what will be the amount of the mixture that I will weigh if the mixture that I produce ay 5,200 milligrams, and in 5,200 milligrams naglalaman siya ng 150 milligrams of the drug. Okay? Ayan. So, yan yung mga values that I have. So, the value of x will be equal to 5,200 times 6.5 divided by 150. Ayan. So, my answer is 225.33 milligrams. Okay? Ayan. So, hindi lang masyado whole number, no? Ayan. Kasi medyo, ano to, medyo impromptu yung inisip ko. Yeah, so I will be weighing 225.33 milligrams or simply 225 milligrams of the mixture, okay? and that mixture will already contain 6.5 milligrams of the drug. Okay? And so basically, that's how Aliquot method of weighing and measuring works. Okay? Now, you can also do another technique. Okay? So this is another technique that you can do. Let us make this 130 instead. Okay? Ano yung kahalagahan ng 130? 130 is basically the smallest quantity that is weighable in the balance. Okay? And so let us set that the amount of the drug that we want to weigh is 130 milligrams also. Okay? So that's 130 milligrams of atropine sulfate. And so 130 divided by 6.5, it's equal to 20. So ibig sabihin, what we produced ay 20 times. Okay? And 20 times more concentrated than what we need. Okay? Now, what you can do is also multiply yung amount of the drug by 20. Okay? And kasi this is already our multiplier from 6.5 milligrams. We multiplied it by 20 to get 130 milligrams. Okay? Now, let's multiply it again by 20, just like what was shown in the first slide. And so 130 times 20, this is equal to 2,600 milligrams. Anong kahalagahan nito? 2,600 milligrams is will be the weight of the mixture. Okay? Yan. So anong ibig sabihin? If the weight of the mixture is 2,600 milligrams, yan, we subtract from it 130 milligrams, which is the weight of the drug. The weight of the aliquot will be the weight of the diluent, I mean, is 2,470. You are correct. Thank you for that. And 2,470 milligrams. Okay. So by mixing 2,470 milligrams of the diluent with 130 milligrams of atropine sulfate, we get 2,600 milligrams of the mixture. The next question is to get 6.5 milligrams of the drug, what will be the amount of the mixture that will be apportioned from 2,600 milligrams of the mixture that contains 130 milligrams of the drug? Okay? Yan. So, actually, madali lang yung sagot dito, but just to show you something, no? 6.5 times 2,600 divided by 130, then our answer is 130 milligrams. Ano itong 130 milligrams? Again, take note that we have already set, okay? We have already set na the weight of atropine sulfate is the smallest quantity, which is 130 milligrams, okay? Now, we increase the amount of atropine sulfate by 20 times. So, the mixture will have to be divided as well by 20 to get 130 milligrams of the drug in the mixture. Okay? Yan. So, 2,600 divided by 20 is 130 milligrams. And that is actually the least weighable quantity method. Okay? Ayan. So, yan din yung isa pang method na tinatawag natin. That's already the least weighable quantity method. The difference between the Aliquot method of weighing and measuring and the least weighable quantity method is simply this. No? In the least weighable quantity method, you will set that the amount of the drug is the smallest quantity weighable in the balance already, and the amount of the powder, okay, is also the least weighable quantity in the balance. Okay? Ayan. So I don't know which one is easier for you, okay? Ayan, but it means the same, okay? Wala namang pinagkaiba yung dalawa, okay? Ayan, the least weighable quantity that you will take from the mixture is still an aliquot, or it is still a fraction or a portion of the mixture. So it's still the same, right? Okay, so I hope you understood that part of our discussion. And kasi hindi ko na discuss itong next na problem because I will now move on to the last problem, no? Ayan. So gawan naman natin ng paraan how to determine the volume of liquids. What if naman liquids yung ating problem? Okay? Yan. So sometimes when you are given a problem that involves liquid measurements, you need to have logic. Okay? You need to follow logic more. Okay? Ayan. So let's use this example. A prescription calls for 0.5 milliliter of hydrochloric acid using a 10 milliliter graduate calibrated from 2 to 10 milliliters in 1 milliliter divisions. Explain how you would obtain the desired quantity of hydrochloric acid by Aliquot method. Okay? Ayan. So, ano-ano yung mga mahalagang malaman dito, no? Um, wala talaga ditong percentage error that is given. Okay? But you are told that the smallest quantity, okay, that is measurable in the graduated cylinder is already 2 milliliters. Kasi sabi diyan, ayan, it can only measure between 2 to 10 milliliters. Okay? The next thing is yung error, yung maximum potential error niya. Remember, it is the measurement that is, it is a quantity that is easily differentiated by the instrument. Okay? It's 1 milliliter. Okay? So, ibig sabihin walang in-betweens. No? Ayan. So, ang kaya lang i-measure ng inyong graduated cylinder ay ag- um, increments of 1 milliliter. Okay? Any smaller than 1 milliliter increments, hindi niya kayang i-measure. Okay? Ayan. So, how are we going to obtain the desired quantity of hydrochloric acid by Aliquot method? Okay? And so, what you can do is this. Take note that 2 milliliters is the smallest quantity. Let us divide from it 0.5 milliliter, which is the amount that you will need to measure. Okay? Ayan. So, yan yung dapat mo talagang i-measure na hydrochloric acid. But you cannot do that because the smallest quantity measurable in your graduated cylinder is 2 ml. So, we need to multiply our hydrochloric acid by 4 times. So, this is now our factor. Okay? So, our factor is 4. Okay? Ayan. So, now, if we multiply it by 4, okay, ayan, now we know that the smallest quantity is 2, okay? Ayan, so 2 yung smallest quantity, so I can also multiply this by 4. Okay, so 2 ml times 4, this will give me 8 milliliters. Okay? Anong ibig sabihin yan? 8 milliliters will be the total volume um, of the mixture or the solution that I will prepare. Okay? Yan, 8 milliliters daw. Can I still measure that using my graduated cylinder? Yes, no? Ayan, pwede pa rin kasi 2 to 10 milliliters yung pwede niyang i-measure. So, ibig sabihin, what I will do is, I will measure 2 milliliters of hydrochloric acid, ayan, and then dilute it to 8 milliliters by adding about 6 milliliters of water, which is my diluent. Okay? Now, if the mixture is 8 milliliters and if it contains 2 milliliters of the hydrochloric acid, ayan, what will be the volume of the mixture or the solution that I will take out, okay, to give me a quantity that is equal to 0.5 milliliters. Ayan. Remember that what we did here is the same as the least quantity method that I mentioned before na wala namang pinagkaiba with the Aliquot method. It's just that we are using the smallest quantity measurable. Okay? Yeah, so we use the same factor. Okay? So, ibig sabihin, this will be equal to 2 milliliters. Now, is it possible? Yes. Okay? So, buuin na natin yung kwento niya. No? So, the kwento now is to deliver 0.5 milliliters of hydrochloric acid, what you do is you um, get 2 milliliters of hydrochloric acid, dilute it to 8 milliliters by adding about 6 milliliters of water, which is the diluent, okay? And then get an aliquot of 2 milliliters from the 8 milliliter solution, which will represent or which will contain zero point 0.5 milliliters of hydrochloric acid. Okay, so that's how you do the least weighable quantity method or the Aliquot method using liquid measurements. Okay, so I hope that one was clear to everyone. And okay, that's actually the end of this part of the lesson. And so we will now move on to our next topic. And if you still have some questions in mind, do not hesitate to ask. Okay, so for our next topic, we have density, specific gravity, and specific volume. Okay, ayan. So here are the objectives for this lesson. To define density, specific gravity, and specific volume and determine each through appropriate calculations. To calculate specific gravity from data derived from the use of a pyknometer and apply specific gravity correctly in converting volume to weight and weight to volume. Okay. And so this is a review also of some of the topics that you may have already discussed in some of your courses, no? Particularly if you had physics or in your elementary science, no? Density and specific gravity. So maybe what's going to be new here is the method, no? Or are the methods of determining specific gravity of both the liquids and solids. So when we say density, it is basically the mass per unit volume of a substance. Okay, and it is usually expressed as grams per cubic centimeter or grams per milliliters because 1 milliliter of water is said to occupy a volume of 1 cubic centimeter. Okay, so the density of water is also given as 1 gram per ml. Okay, so remember that the density has this formula that is mass divided by volume. Now, you can, of course, use other units for mass, and you can also use other units for the volume. Yes. And so to um, to whoever ask question, the answer is yes. Yeah. So um, yeah, so you can use a different volume, a different unit, no, for the mass and also for the volume. Okay, for example, you can use pound. Okay, for the mass, you can also use uh, fluid ounce for the volume. Okay, you can also use cubic feet for the volume. You can use milligrams for the mass. No, and so that's what differentiates density from specific gravity. Okay, density has a unit and the unit should always be specified. Okay, because the numerical value of density varies with the unit that you use in expressing the density of any material. Okay, and so take note of that. Now, the specific gravity, okay, on the other hand, is a ratio, okay? It is a ratio of the same quantity, okay? It is a ratio that is expressed decimally of the weight of a substance to the weight of an equal volume of a substance chosen as a standard. For example, water for liquids and also solids, and hydrogen for gases. Both substances should be determined at the same temperature, or the temperature should be known for each of these substances. Okay. Um, now, the density is a quantity. Okay, with a unit. Okay, so remember that it is a quantity with a unit as opposed to specific gravity, which is a quantity without a unit. Okay, so meaning to say, density is a concrete number, okay, while specific gravity is an absolute number, okay? And so remember what we discussed before, okay, when it comes to numerals and numbers, okay? Kapag may units, no, we call it a concrete number, okay? And kapag wala naman, we call it an abstract number or an abstract numeral, okay? Ayan, so the reason why specific gravity does not have a unit, it's because it is a ratio, okay? So the ratio has these two quantities of the same units. Okay, so weight of the substance divided by weight of an equal volume of water. Okay, water being used as a standard for both liquids and solids. Okay, so if the weight of the substance is expressed in grams, then of course the weight of an equal volume of water should also be expressed in grams. Okay, and we can cancel the units. So specific gravity is a unitless quantity. Okay, now are density and specific gravity constants? Can we use density and specific gravity for determination of identity of a particular object? Yes, both are physical constants. Okay, yeah. So at a given temperature and or in general, no, under given conditions, no, at a given set of conditions, both specific gravity and density are a constant value for any object, and it can be used as one of the means to determine the identity of a material. Okay? Yan, kasi it should not vary, okay? Um, in a particular material unless the material is impure, no? If the material contains other substances, then the specific gravity and the density will vary, okay? Now, both of them are physical constants, but the numerical value of a specific gravity is always a constant, okay? Because of the fact that it is a unitless quantity. The density, while it is a physical constant, will have various numerical values depending on the unit that is used to express the density. Okay? But again, okay, these values are only constants if they are taken at identified standard temperatures or in general um, understated experimental conditions. Okay. Now, how can we use density and specific gravity? Okay. Now you know this from your other subjects probably, you know, na if we know that density of water is 1 gram per ml, so its specific gravity is also equal to 1 at 25 degrees Celsius. Most of the time, pharmaceutical substances are measured at 25 degrees Celsius. It is the official or the standard temperature. Okay, yeah, that's why we use that, except for ethanol, okay, or alcohol. Now, for alcohol, the specific gravity is taken at 15.56 degrees Celsius under government regulations or because of government regulations. Now, by observing the numerical values of both density and specific gravity, we can say if a material is lighter than water or heavier than water. Okay, so if the density or the specific gravity has a value of greater than 1, okay, or 1 gram per ml in density, then we say that that particular substance is heavier than water. Okay, so what you can see in this table is that all these materials and with specific gravities greater than 1, the specific gravity of water, all of these are heavier than water. Okay, so when you mix them with water, they will sink, okay, at the bottom of the water. That's why in your inorganic pharmaceutical chemistry, okay, when you test for the presence of halogens, in particular bromine and iodine, okay, you observe the color of the bromine or iodine at the bottom of the two layers. Okay, di ba mayroon kang two layers, you observe the color at the bottom. Okay, because the chloroform has a specific gravity greater than 1. so it is heavier than water. Okay. Now, all of these materials whose specific gravity are less than 1 are considered to be lighter than water. Yan. So they are on top of water when you mix them with water. Okay. Now we know that oil and water do not mix. Okay. And most oils, again, most oils, not all. Okay. Most oils are on top, okay, of your water. Okay. So initially, when you pour oil on your water, okay, magmi-mix muna sila temporarily, but because of hydrophobic interactions, I hope you have already discussed that in your in your organic pharmaceutical chemistry, because of hydrophobic interactions, oil globules will coalesce, they will combine together, and they will separate from water. Okay, and most oils are lighter than water, so you will find them at the top. Okay, yan, of water or the aqueous layer. Okay? Now, there are certain oils na heavier than water, like clove oil. Ayan. It's heavier than water. Okay? Now, addition of solutes in water can also increase the specific gravity of water. Okay? For example, when you add glycerine or syrup, ayan, or sucrose, I mean, to produce syrup in your water, the specific gravity increases. Okay. And that is actually the principle of one one profession, okay? I don't know what to call it. One career, okay, which is bartending, no? Ayan. I don't know if you're familiar with this, okay? But your cocktails, I know that you are already old enough to drink cocktails, right? So there are certain cocktails with layers, okay? And so the principle that is involved there is actually the differences, no? Ayan, they make use of the differences in the density or the specific gravity of the materials. Okay? The greater the amount of ethanol, okay? And kasi yung alcohol has a lower specific gravity than water. Okay? So the greater the amount of alcohol, okay, in a particular drink, okay, the lighter it is, okay, than water. So it will be on top. Now, the more sugary, okay, the greater the amount of sucrose in the um, in the in the drink, okay, the heavier it becomes. Okay, kasi nga yung addition of solutes heavier than water will most definitely increase its specific gravity. So it will be at the bottom. Okay, yeah. So let's watch this very very short video just for you to appreciate the importance of a specific gravity and density, no, in other things that you might be familiar with.
This is how you layer a cocktail. This technique you can use for layering different liquids on top of each other with different densities. So what you have to look out for is the amount of sugar and the amount of alcohol. So what I'm going to start off with this shot is 3 liquids. And I'm always going to start with the liquid with the most amount of sugar, in this case the Bols Blue. So pour that in first. So for the next layer I like to use a bar spoon with a flat end, so I can rest that on the previous layer. I'm getting my triple sec into the spoon and really slowly pour the liquid down the stem of the spoon. And it creates a really nice layer. The slower you do this, the nicer your layer will turn out. So you want to try to end up with equal parts. And the last one is the one with the most alcohol and no sugar. In this case, barrel-aged Geneva. And pour that slowly down the stem of your spoon. And that ends up to be your last layer. And that is how you layer a cocktail.
Okay, so that's it, no? And so take note na the greater the amount of the solute in the drink or in the water, ayan, the heavier it becomes, no? So it goes down, it settles at the bottom. But the greater the amount of the alcohol having a specific gravity that is lower than water, the more that it floats on top of the heavier ones. Okay, and so basically, yun yung application niya, no, in bartending, in cocktail making, etc. Ayan. Ayan. So, okay. So sana medyo nagising kayo on that because it's almost 10:30. Ayan. Okay. Okay. Another application of specific gravity and density, and now you know, ayan, what to do. Ayan. At saka another thing that I would like to point out there, no, is the use of a steering bar, okay? Again, to guide the liquid so that it will not thoroughly mix with the other liquid, okay? That is also an essential technique in pharmacy, okay? Whenever you transfer a liquid from one container to another, okay, especially when you are pouring solutions, okay, into a container na narrow yung brim, okay, or smaller yung mouth, you use a steering rod to guide the liquid, okay, to prevent spillage, okay, of the liquid, okay. Ayan. Now, if you are a pharmacy student or a pharmacist, okay, even in your own homes, no, you will do that, no? Ayan, para hindi matapon yung liquid, you will guide it using your spoon, ayan. Ayan, para or yung straw pag may straw kayo. Ayan. Yung iba nga nagpa-practice mag-pipette using straw, no? Ayan. So those are some peculiarities that we have in our profession here, no? Another application of density and specific gravity is this, no? And aside from those that are already written in your online module, and by the way, the deadline is way past pa naman, November 4th. Ayan, so you'll have enough time for you to answer those. Is in the separation of the components of whole blood. Okay. Now, when we say whole blood, that's normally the blood that is taken from you. Okay, so ito yon. Okay. Now, by using centrifuge, okay, the different components of the blood will separate depending on their specific gravity or density. Okay. The portion of the blood which contains formed elements. Okay, ito yung ating mga leukocytes, yung um, platelets, erythrocytes. Okay, they will be in this portion at the bottom. Okay, yan kasi they are heavier than the plasma. Okay, some proteins can be found in the plasma. Okay, yan, so siya yung humihiwalay on top. Okay, yan, so by using centrifugal force, you can actually separate different components of the blood through um, based on their density or specific gravity. Okay? Yan. So, yun yung mga applications niya. Now, let's proceed to our discussion. Now, we can determine specific gravity of liquids using two methods. The first method is the pycnometer method, and the second method is the displacement method or the plummet method. Okay. Now, the way that you compute for the specific gravity in both of these methods are different. Yeah, so please take note of that. Okay. Now, remember that our formula for specific gravity is weight of the substance divided by the weight of an equal volume of um, a standard, which is water, in most solids and liquids. Okay. Yeah. Now, the pycnometer is also known as a specific gravity bottle. It is a bottle that has a specified capacity. Okay. So it looks like this. Okay. So the capacity of the pycnometer is most often written, ayan, in the bottle. There can be pycnometers na as small as 5 milliliter. Ayan, yung capacity up to sometimes 50 na nga, no? Or even higher. I've seen 100 milliliter pycnometers before. In place of the pycnometer, you can also use a volumetric flask, although that is not advisable if you have a pycnometer. Okay. Now, in the pycnometer, you have a ground glass, okay, and stopper. Ayan. So, yung stopper niya ay ground glass because it will really close the container and it will prevent any bubbles, okay, doon sa inyong container. Another way that it prevents formation of bubbles inside the container is through the capillary that is in the stopper. Okay, so yung stopper niya ay may butas. Unlike your volumetric flask, okay, whose stopper is solid, okay, wala siyang capillary, okay? Now, what you do is first you fill the pycnometer to the brim, okay? Ayan, until there is a concavity of liquid on top of or on the mouth of the pycnometer, okay? And then you carefully place the stopper, ayan, doon sa inyong pycnometer, and definitely the excess of the liquid will move to the capillary and some will actually spill over doon sa capillary hole of the stopper. Okay? Then you will need to wipe the excess dry, okay, before you weigh the pycnometer. Okay? Now you do that on both the substance and the standard, which is distilled water. Okay? Um, why do we need the pycnometer? The pycnometer has a specified volume. Okay? So whatever substance is placed in the pycnometer, provided there are no bubbles inside the pycnometer, their volumes will be the same. Okay? Remember that the formula for specific gravity is this, no? It is the weight of the substance divided by the weight of an equal volume of the standard, which is water. Okay? Yan. So, importante ito, no? Both the substance and the distilled water should have the same volume. So, by putting them in a pycnometer, you are assured that their volumes are the same. Okay? Ayan. So, let's apply this formula in the pycnometer method. Okay? In this problem, you have a 50 milliliter pycnometer found to have a weight of 120 grams when empty and 171 grams when filled with water and 160 grams when filled with an unknown liquid. Calculate the specific gravity of the unknown liquid. Ayan. So the specific gravity of the unknown liquid or the substance will be equal to the weight of the pycnometer with the unknown liquid, ayan, and that is 160 grams minus the weight of the pycnometer, which is 120 grams. Okay? Divided by the weight of an equal volume of water. So meaning to say, it is the difference between 171 grams, which is the weight of the pycnometer with water, and 120 grams, which is the weight of the empty pycnometer. Okay? So what you have is 160 minus 120 grams, that's equal to 40 grams divided by 171 grams minus 120 grams. So that's equal to 51 grams. So the specific gravity is, the specific gravity is equal to um, 0.7843. Okay? Remember that the grams will cancel out. So there is no unit. So it's approximately equal to zero point 0.8. Okay? Ayan. Yan. Or 0.78. No? Ayan. So, correct. Now, according to the USP, you can actually express a specific gravity using 2 decimal places, 3, or even more, depending on the accuracy of the instrument that is used. Okay? Ayan. So, most of the time, I will express the specific gravity using 1 or 2 decimal place. Okay? Ayan. But if we will follow yung discussion natin from before, okay? Ayan, remember kapag nag-divide tayo, ayan, so you will use the numeral with a smaller number of significant figures. So, ibig sabihin 1. Okay? So, dapat mga 0.8 lang siya. Okay? Ayan. So, ito yung more accurate answer. Okay? If we base it off the rules of rounding off. Right? Okay. Ayan. So, sana nakuha ninyo yung method na yon, picnometer method. Now, remember na I also mentioned before density. Okay? Remember that density, which has a symbol of letter D or sometimes rho. Okay? In physics, we use the symbol rho, the Greek letter rho, no? Ayan. So ito yung symbol for rho. Density is mass of the substance divided by its volume. Okay? Now, how do you express this, or what do you think is the density of the liquid in grams per ml? Okay? Ayan. So we can also use the same values or quantities that are written here. Okay? Ayan. So the density is equal to the mass of the substance. So ano yung mass of the substance? The mass of the substance is this, 160 grams minus 120 grams. But may minus. Kasi 160 grams is the weight of the picnometer with the unknown liquid. So you need to subtract the weight of the empty picnometer. Okay? Yeah, so 160 grams minus 120 grams divided by the volume of the picnometer. What is that? It is this. Okay, so the volume of the picnometer is basically the volume of whatever liquid that you put there. Okay, yan. So the volume of the substance is 50 milliliters, and this is equal to zero point 0.8. Okay, which is numerically the same as its specific gravity, except that the density has a unit that is grams per ml. Okay, so I hope that is clear because we will be moving on to the next. Ayan. So the next one is the plummet method or the displacement method. Okay. Um, if you have already watched the videos that I posted in the learning module, um, you may have already learned about the exclamation by Archimedes, okay, when he discovered a solution to a problem that was given to him by the king, okay, and he said Eureka, no, ayan. So yun daw yung exclamation niya. But initially, no, we are told even in high school that um, Archimedes was asked to determine whether the crown is pure gold or not. Okay? That has already been disproved. Okay? Hindi raw yon yung totoong dahilan why Archimedes exclaimed Eureka, no? And how he discovered the displacement method and the law of buoyancy. Okay? Ayan, so it has something to do with a ship. Okay, and so please watch those videos. Those are very enlightening. No? Ayan. So remember that um, the specific gravity and the density are both considered to be physical constants for any object. So when you know the specific gravity of a particular object, you can determine its purity as well. Okay, because if the specific gravity is not the same as its theoretical specific gravity, then it will be considered to be impure. Okay, so basically that's the idea. Okay, behind the experiment by Archimedes. Okay, this Archimedes is a Greek mathematician, which is very close to my heart because my section in high school during my first year ay Archimedes. Okay, and so I will always remember Archimedes. And so, what is this displacement method? It is based on the Archimedes principle or the law of buoyancy, which states that a body immersed in a liquid, and so take note of this word, immersed in a liquid, displaces an amount of the liquid equal to its own volume and suffers an apparent loss in weight equal to the weight of the displaced liquid. Okay? So ano yung ibig sabihin yan? So suppose we have here a liquid. Okay? Now, let's say that you have an object with an irregular shape. Okay? You can determine the volume, okay, of this irregularly shaped material by putting it in a bath, of a liquid with a known volume. Okay, so let's call this x naught. Okay, now when I put the irregularly shaped material in the bath of the liquid, and there will be a change, okay, in the volume measured, and let's call it x1. Okay, the volume difference, okay, between the two, see x1 minus xo, this is now the volume of our object. Okay, that's the volume of the irregularly shaped solid. Okay, but that is only true when the solid is completely immersed in the liquid. Okay, yan. We'll have to do adjustments if the liquid is not completely immersed in the liquid. Okay, now because the liquid also has an opposing force, okay, a force that opposes the force of gravity. Okay, remember that this material has a mass of m. Okay, so meron siyang acceleration due to gravity. Okay, and yun yung force niya downwards. Okay, yung mass times its acceleration due to gravity, yun yung force niya downwards. Now there is a force, basically that's the weight. There is a force that counteracts that weight. Okay, and that force is what we call the buoyant force. Okay, now the buoyant force reduces the apparent weight of the object. Now the mass does not change, but the weight appears to change. Okay, and the apparent loss in weight of the solid is basically the same as the weight of the displaced liquid. Okay? Yan. So, ang sinasabi lang niya is that whatever amount of liquid was displaced by the solid, okay, has a weight. Okay? And that weight is the same as the apparent loss in weight in this object. Okay? So, those are the two things that Archimedes' principle mentioned. Okay? One is that when an object is completely immersed in a liquid, the liquid will have a change in volume. The change in volume will be the same as the volume of the solid that is immersed in it. Okay, or the displaced uh, liquid will have a volume that is the same as the volume of the solid immersed in it. Okay. The second principle or the second thing that you have to remember is that the apparent loss in weight in the solid or in the object will be equal to the weight of the displaced liquid. Okay. There are also a couple of photos that I have here, no, illustrating Archimedes' principle. Okay, now this is important because for certain regular shapes, okay, or regularly shaped solids, we can easily determine their volumes, no, by formulas that you probably have memorized before, okay. But for irregularly shaped objects, we cannot easily determine their volumes, okay. So we can employ the Archimedes principle to determine the volume of irregularly shaped um, solids. Okay. Now the weight, okay, this weight, okay, the weight of the displaced liquid is the same as the weight that pushes, okay, or the buoyant force, okay, that pushes the object in the liquid that immerses the solid. Okay. Yeah, so those are the photos that I have here. Okay. Now, how do we apply the displacement method or Archimedes principle in the determination of the specific gravity? Okay. Yeah, so it's easier to explain this by using a problem. Okay. Yeah, so let's take this problem. For example, a glass plummet weighs 12.64 grams in air, 8.57 grams when immersed in water, and 9.12 grams when immersed in an oil. Calculate the specific gravity of the oil. Okay. And so take note that instead of using a pyknometer, what we are using this time to determine the specific gravity of the oil, okay, is a glass plummet. Okay, why glass plummet? The glass plummet has a certain volume, okay, and its volume will be the same wherever you placed the plummet. If you place the plummet in water, its volume will be the same. Okay? When you place it in oil, let's say this is the oil, its volume will also be the same. No? Imposible namang magbago yung volume ng glass plummet. It will be the same in both liquids, right? Now, take note that the glass plummet will displace an amount of the liquid equivalent to its volume. Okay? So in water, the displaced volume is this. Okay? And that volume, okay, is the same as the volume that is displaced in the oil. Okay? Ayan. So G for glass plummet. Okay? Ayan. So the volume displaced by the glass plummet in both water and oil are the same. Okay? Now, let's look back at the formula ng specific gravity. Specific gravity is equal to the weight of the substance, okay, um, divided by the weight of an equal volume of water. Now, what is the substance that we are trying to determine here? We are trying to determine the specific gravity of oil, so the weight here is the weight of the oil. Okay? Now, the oil and the water should have the same volume. Okay? Now, saan manggagaling yung same volume na yon? Manggagaling yun sa displaced volume. Okay? Remember that the glass plummet will displace the same volume in water and in oil. Okay? So, if we will know the weight of the displaced water and we will know the weight of the displaced oil, we will know these values. Okay? Yan. So, basically, yun lang sinasabi niya sa atin. Okay? So, in the displacement method, we can determine the specific gravity of the liquid, okay, as the apparent loss in weight of the glass plummet in oil divided by the apparent loss in weight of the glass plummet in water. Okay? So, yan yung magiging bagong formula natin. Okay? A specific gravity is the ratio of apparent loss in weight of the glass plummet in oil to the apparent loss in weight of the glass plummet in water. Okay? Um, Again, ulitin natin na um, the weight, okay, of the displaced liquid, okay, ayan, yung weight ng displaced liquid is the apparent loss in weight, okay, of the object that is immersed in it. Okay? And that's why we will use the apparent loss in weight in both liquids. Okay? So now we can determine the specific gravity of the oil. Okay, so the apparent loss in weight of the glass plummet in oil is equal to 12.64 grams, the weight of the glass plummet in air, minus 9.12 grams, which is the the apparent weight of the glass plummet in oil, divided by, again, 12.64 grams, the weight of the glass plummet in air, minus the apparent weight of the glass plummet when immersed in water, and that is 8.57 grams. Okay? So if you calculate that, the value that you will get is 0.86. Okay? Now take note that this value is less than 1. Okay? Now, the question is the oil heavier or lighter than water? Because the oil has a specific gravity that is less than 1, then we can say that the oil is lighter than water. Okay? And so I hope you were able to get that. Moving on. The important thing about the displacement method is we can apply it in the determination of a specific gravity of solids as well. Okay? Ayan. So, iba na to, no? Ayan. So, in the first part, ayan, I discussed to you methods of determining specific gravity of liquids. There are two ways, the pycnometer method and the plummet method or the displacement method. Now, in this part of the discussion, I will be showing to you the methods to determine specific gravity of solids, okay, and the principle behind the methods of determining specific gravity of solids ay displacement method as well. Okay, ayan. So let's begin with solids which are heavier than and insoluble in water. Ayan. So just like before, it's easier to describe this using an example. Okay, so remember that the substance is insoluble in water and it is heavier than water. Because the solid is heavier than water, we are assured that the solid will be completely immersed in water. Okay, so the method is very much similar to the plummet method of determining specific gravity of liquids, but this time around, we are determining the specific gravity of the solid. Okay, ayan. So, what do we need? Okay, so remember that the formula for specific gravity is equal to the weight of the substance, this time the solid, divided by the weight of an equal volume of water. Ayan. Now, where do we get the weight of the solid? The weight of the solid is basically the weight of the solid in air. Okay, so that's 38.525 grams. Okay, yan. So remember, ang dinedetermine natin dito is the specific gravity of the solid. Okay, now where do we get the weight of an equal volume of water? Okay, so just like in the plummet method, yan, when we immerse any object in a particular liquid, it will suffer, okay, an apparent loss in weight that is equal to the weight of the displaced liquid. Okay? So by determining the weight of the displaced liquid, okay, we can determine the weight by determining the apparent loss in weight, okay, sorry, of the solid, we can determine the weight of the displaced liquid. Okay? Now, that displaced liquid has the same volume as the solid that is immersed in it. Okay? So, yun na yung weight of equal volume of water. Okay? It is now the apparent loss in weight in the object as it is immersed in water. Okay? So this will be equal to 38.525 grams minus 23.525 grams. So the specific gravity of the solid is equal to, ayan, 2.57 or 2.6. Okay? Ayan. So that's how we employ the displacement method in the determination of a specific gravity of solids. Okay, so moving on, what if no we want to determine the specific gravity of a solid, okay, that is heavier than water but it is soluble in water. So pag nilubog mo siya sa tubig, it will simply dissolve. So how are you going to determine the specific gravity of that particular solid? Okay, let's suppose um, a huge chunk of tawas, no? And I'm not sure if you are familiar with tawas. Okay? So tawas is basically your potassium or ammonium alum, okay? Which you will discuss in your inorganic pharmaceutical chemistry. And it is soluble in water. Okay? So if you would like to determine the specific gravity of a huge chunk of tawas, okay, this is what you are going to do. Instead of using water as the immersing liquid, you will use a different substance, okay? A substance where the solid is insoluble, okay? Ayan, so let's say an oil, okay? Ayan, so an oil will not dissolve the water-soluble substance, okay? Kasi magkaiba sila ng intermolecular forces of interaction. Now, take note that the weights of equal volumes of any two substances are proportional to their specific gravities. Now, if we know the specific gravity of the oil, we can already determine the specific gravity of any object that is immersed in it. Okay? Ayan. So, how are we going to do this? Okay? Ayan. So, let's take, for example, ayan, this problem. You have a crystal of a chemical salt that weighs 6.423 grams in air and 2.873 grams when immersed in an oil having a specific gravity of 0.858. What is the specific gravity of the salt? Okay, ayan. So what can we first determine? Okay. So we can actually first determine the weight of the displaced oil. Oops, hold on. Ayan. So weight of the displaced oil. So the weight of the displaced oil is the same as the apparent loss in weight and the apparent loss in weight of the salt in oil. Okay? So that will be equal to 6.423 grams minus 2.873 grams. Okay? Ayan. So ayan yung kanyang apparent loss in weight. Okay? And that will be equal to 3.55 grams. Okay? So what is this weight? This is the weight of the displaced oil. Now, the displaced oil has the same volume as that of the salt. Because according to Archimedes' principle, any solid immersed in any substance will displace the same volume as it, no? Ayan, as its volume. Okay? Ayan, so yung volume ng displaced oil na to will have the same volume as the salt. Okay? So, ibig sabihin, we can say that 3.55 grams is the weight of an equal volume of oil. Okay? Ayan, sounds familiar now, right? Ayan, so the next thing that we will do is we will use the specific gravity of the oil. Ayan. So this is 0.858. Ayan. Sabi doon sa previous slide, the the weight of any substance is proportional to its specific gravity. Okay? Now, the oil that is displaced has a weight of 3.55 grams and its specific gravity is 0.858. Okay? Now, an equal volume of solid, okay, the chemical salt has a weight of 6.423 grams. Okay? Now, we can determine the specific gravity of our solid already. Yung nasa numerator ay yung solid, yung nasa denominator ay yung oil. Okay? Ayan. So, by simply moving the numerical values, 0.858 times 6.423 divided by 3.55, we get a value of 1.55. That's the specific gravity now of the chemical salt. Now, there is another way for you to do this. Okay? And so, if you would like to use yung same principle as before, gagamitin natin yung formula that we have for specific gravity. Why not? No? Ayan. So, anong ibig kong sabihin? We know the weight of the displaced oil. Okay? And we also know the specific gravity of the oil, which is 0.858. Okay? Now, if we would like to know the weight of the displaced water, okay? Kasi according nga sa formula ng specific gravity, it is the weight of the substance over the weight of an equal volume of water. Right? Ayan. So gusto mong makuha talaga yung weight of equal volume of water. Okay? Now, for you to determine, okay, the weight of an equal volume of water, X, okay, we need to use the specific gravity of, the specific gravity of water. Okay? So, ito ay specific gravity of water, ito ay specific gravity of oil. This is the weight of the displaced oil, and X will be wag na lang X, A na lang, A. A will be the weight of the displaced water if water were used as the immersing liquid. Okay? So, A will be equal to, ayan, 3.55 divided by 0.858, and that is equal to 4.1375. Now, it has a unit grams. Okay? But we are not yet done with our formula. Okay? So, we will still use this. And specific gravity of the substance is equal to the weight of the substance, which is 6.423 grams, divided by 4.1375 grams. Okay? And so, 6.423 divided by this, okay, will be equal to the same answer, 1.55. Okay? Yan yung specific gravity of the chemical salt. Okay? And so moving on. And so what if we have a solid that is lighter than and insoluble in water? Okay? And so before I proceed, I would request permission from you We will extend a little bit, okay, yan, to discuss some of the concepts in the next slide, okay? Ayan. Okay, so what if we have a liquid, pero if you're opposing, why, okay naman. I will be posting the recording anyways, okay? Ayan. But the coverage is still until the last learning module 6, no? Reducing and enlarging formulas. Okay? Ayan. Kasi we will lose, we, yeah, another, yan. Okay. Ayan. So, what if the substance is lighter than water? Okay, ito na yon. Now, if the substance is lighter than water, ayan, remember yung principle na sinabi ni Archimedes principle, ni Archimedes, no? Sabi lang naman niya, if the liquid is immersed, ay if the solid is immersed in the liquid, okay, it will displace the same volume, okay, as its volume. Okay? Ayan. Pero kapag hindi siya completely immersed, okay, for example, we have an object that is lighter than the immersing liquid, okay, yung displaced liquid will have the same volume lang of the uh, part of the object that is immersed in it. Okay? Hindi lahat. Okay? Ayan, so kunwari, ito lang yung immerse sa kanya. Okay? So, yung volume that it displaces ay yung the same volume lang of the material that is immersed on it. Okay? Not the entire thing. Okay? And therefore, yung buoyant force, okay, ayan, gano'n pa rin naman, no? The buoyant force that pushes the solid is the same as the weight of the displaced liquid. However, the volume of the displaced liquid is not the same as the volume of the solid kasi some part of the solid remains floating or afloat in the liquid. Okay, so we need to do something else. Okay, so for you to be able to do that, what you do is you put a sinker. Okay? Ayan. So you put a sinker in the object to fully immerse it doon sa liquid. Okay? Ayan. So by putting the sinker, ayan, so kunwari naglalaro kayo ng sipa noon, yung tansa, okay? It is a sinker. It pulls down any object that may float in water. Okay? Ayan. So it will drag down the material. Okay? Ayan. So you put a sinker. Okay. Now, you need to know the weight of the sinker in water. Okay. Ayan. So, you need to know the weight of the sinker when it is immersed in water. Kasi you will remove that, okay, in the equation. Okay. Tatanggalin mo yan sa inyong formula. Okay. Ayan, so I hope maliwanag yon, no? Ayan, so let's take for example this one, no? A piece of wax weighs 16.35 grams in air and a sinker weighs 32.84 grams when immersed in water. Ayan, when they are fastened together and immersed in water, their combined weight is 29.68 grams. Calculate the specific gravity of the wax. So what we need to know is what is the weight of the displaced liquid equivalent to the volume of the solid. Okay? Ayan. So, yan yung gusto nating malaman. What is the weight of the displaced liquid equivalent to the volume of the solid? Okay? So, for us to be able to determine that, ang kailangan natin is we need the weight of the object in air. So, 16.35 grams, that's the weight of the object of the wax in air. Okay? Now, when you add to it, okay, yung weight ng sinker, okay, in water, 32.84 grams. Okay, so ito ay weight of sinker in water. Ito ay weight of the wax in air. Okay? Now, this is the combined sum, okay, ng weight of sinker in water and weight of wax in air. Now, when we subtract from it the combined weight of the sinker and the wax, okay, in water, yan, which is 29.68 grams, okay, basically, dalawa yung laman nito, okay? Ito ay weight of wax in water when it is completely immersed. Okay? And yung weight of sinker in water. Okay? Ayan. So, dalawa yung ibig sabihin yan. Okay? The weight of wax in water when it is completely immersed in water. So, meaning to say, the volume that it displaces is the same volume as the wax. Okay? And the weight of the sinker in water. Now, we have or we know the weight of the sinker in water. So, pag sinubtract nga naman talaga natin ito, mawawala ito. Okay? Right? And so mawawala ito, weight of sinker in water. So what we will be left with ay weight of wax in air minus weight of wax in water. Okay? And that is now the weight of the displaced liquid equivalent to the volume of the wax, which is our solid. Okay? So 16.35 plus 32.84 minus 29.68, that is equivalent to 19.51 grams. Okay? Now we can already determine the specific gravity of our wax, and that is the weight of the substance, which is 16.35 grams. That's the weight of the wax in air divided by 19.51 grams, which is the weight of the displaced liquid or water equivalent to the volume of the wax. Okay? And that is equal to 0.84. Okay? As we have noted, okay, or as we can note from this value, the wax is indeed okay lighter than water because its specific gravity is less than 1. Okay? Ayan. So moving on, ayan. What if we have granulated solids? Okay, ayan. So iba naman to. What if may granulated solids tayo and these are heavier than and insoluble in water? Okay, so how do we calculate the specific gravity of these solids? Ayan. So we have this example. A bottle weighs 50 grams when empty and 96.8 grams when filled with water. Okay? If 28.8 grams of granulated metal are placed in the bottle and the bottle is filled with water, the total weight is 118.4 grams. What is the specific gravity of the metal? Now, take note that when the metal is put in the specific gravity bottle, the same as your picnometer or pwede rin naman na volumetric flask, okay? It occupies a space. Okay, and that space it occupies is its volume. Okay, the volume that it occupies has an equivalent weight as well, and that is the weight that we need to determine. Okay, and the weight of the space that is occupied by the granulated metal. Okay, so how are we going to do this? Okay, so first is that we need to determine the weight of the water that fills the bottle. Okay? Ayan. So, paano natin yung malalaman? And we know that when the bottle is empty, it is 50 grams. When filled with water, it is 96.8 grams. So 96.8 grams minus 50 grams will be equal to 46.8 grams. So this is the weight of the bottle that fills, this is the weight of water that fills the bottle. Okay? The next thing that we need to do is now we know that this is the weight of water. What else do we know? We know that the metal weighs 28.8 grams. Okay, we can add those two together. So 46.8 grams plus 28.8 grams is equal to 75.6 grams. Okay, this is the combined weight of water and the granulated metal. Okay, yan. Now, take note na yung weight na ito ng water has a volume that is the same as the volume of the bottle. Okay? Ayan. So yun yung ayun yung capacity of the bottle. Okay? Now, when you place, okay? When you place the metal in the bottle with water, okay, the combined weight becomes 118.4 grams. Okay? Anong ibig sabihin nun? Ito yung ating bottle. Okay? Ito yung granulated metal. Its weight is 28.8 grams. Okay? Now, that metal displaces a certain volume of water. Okay? Tapos, we know that the weight of the bottle and the water and the metal ay 118.4 grams. What we don't know ay yung weight ng water that remains, okay, doon sa inyong bottle, or the weight of the water that is displaced by the metal. Okay? So how are we going to determine that? Okay, so first is you will subtract from 118.4 grams 50 grams, just like what we did over here. Okay, so to determine the combined weight of water and metal in the bottle. Okay, yeah, so this is equal to 68.4 grams. Okay, so this is the combined weight of water and metal in the bottle. Okay? Notice na this amount is greater than this. Okay? Anong ibig sabihin nun? The difference between the two will give you the weight of the water that is displaced by the metal. Okay? So 75.6 grams minus 68.4 grams. This is equal to 7.2 grams. Okay? This is the weight of water that is displaced by the metal. Okay? Ayan. So, anong ibig sabihin yan? This is now the weight of an equal volume of water, which we can now use in the calculation of specific gravity of the metal. So, the weight of the metal in air is equal to um, 28.8 grams divided by the weight of an equal volume of water, that is 7.2 grams. So this is equal to 4 or 4.0. Okay? Yeah, so that's now the specific gravity of the metal. Okay? Yan. So now what is a specific volume? A specific volume is basically the reverse or the inverse of specific gravity. A specific volume is actually equal to the reciprocal of a specific gravity, okay? Or it is equal to the volume of the substance divided by the volume of an equal weight. Ayan, so mali ito. Ayan, the volume of an equal weight of water. Okay? Ayan. So, instead of using weight here, volume naman. Okay? That's why we call it a specific volume. Now, the thing is reversed. Okay? If the specific volume, we know that water has a specific volume of 1 still, because the inverse of 1 is equal to 1. Okay? So if the specific volume of any substance is less than 1, it means na it is heavier than water. If the specific volume of any substance is greater than 1, then we know that it is lighter than water. Okay? So we just reverse, okay? What we know about specific gravity for specific volume. Ayan. Now, how do we now use this, no, in our calculations of weights and volumes? Just remember these formulas, although there is no need for you to remember these formulas. Okay. What I normally do is I put an imaginary unit in the specific gravity, that is gram per ml. Although wala talaga siyang unit. Okay. Pero what is this for? Okay. Kasi I know na 1 ml, okay, of water, which is 1 ml of water, okay, which is basically what this stands for, and I equivalent or has a weight of equal to 1 gram. Okay? Ayan, so basically it's the same. Okay? So whenever I see a specific gravity, I put an invisible unit, that is grams per ml, to help me in calculating the weight or the volume of a liquid or a solid given its volume or weight respectively. And so we'll just have some examples. Ayan. So first one is, what is the weight of 60 milliliters of peppermint oil having a specific gravity of zero point 0.9? Okay? Yeah, so again, when you want to determine the weight of a substance, okay, you simply multiply the volume by the specific gravity, okay? So to get the weight of the substance, this is the volume of the substance times its specific gravity. So we get ayan, 60 times zero point 0.9, ayan. So 60 times zero point 0.9 is equal to 54. So the weight of peppermint oil is equivalent to 54 grams. Now, is the substance lighter or heavier than water? Because the specific gravity is less than 1, then the substance is lighter than water. Ayan. Next is, what is the weight in grams of 1 fluid ounce of clove oil with a specific gravity of 1.04, 1.04, okay? Now, remember that the specific gravity, okay, ay a ratio of the grams of a substance per unit gram of an equal volume of the standard, which is water, okay? So for you to be able to use this measure, okay, you need to convert it to metric system. Okay, yan. So hindi tayo gumagamit directly ng English units, either a Voodoo system or apothecary system in calculation of weights or volumes involving specific gravity. Okay? Ayan. So dito papasok yung inyong inaral in the previous module na conversion of units. Okay, so we know that 1 fluid ounce is equivalent to 29.57 milliliters. Okay, now to determine the weight of the clove oil, and I simply multiply the volume 29.57 milliliters by its specific gravity, which is 1.04. And so the weight of the substance is equal to 29.57 times 1.04. And so this is equal to 30.75 grams. Okay? Yan. So the unit will now be in grams. Okay? Yan. Kasi remember na um, itong 29.57 kasi, ayan, you may wonder nga pala, no? Hindi ko pala to na-expound. Bakit ganun, sir? Eh, wala namang unit ito, di ba? Sabi mo, grams per grams yan. Pero this one is in ml. Why is this is still true? Okay? Because we know that for any substance, no, um, let's say yung clove oil natin has a volume of 29.57 milliliters, that can be converted to 29.57 milliliters then of water. Okay? Ayan. So remember, yung denominator in the specific gravity is always weight of an equal volume of water. Okay? Now, if the volume of our substance is 29.57 milliliters, okay, then it has an equal volume of water that is 29.57 milliliters. The good thing about water is that it has a constant gravity, density or specific gravity which is equal to 1. Okay? Yeah, so 1 gram per ml, gamitin natin na lang yung density niya para mas madali. We cancel out milliliters, so ibig sabihin, 29.57 milliliters of water has a weight of 29.57 grams. Okay? So numerically, okay, 29.57 milliliters is the same as 29.57 grams of water with the same volume. Okay? So we can simply multiply it by the specific gravity. We get 30.75 grams of the oil. Okay? And so that's how you do it. And I think this is the last couple of slides. What is the volume in milliliters of 100 grams of glacial acetic acid with a specific gravity of 1.05? Okay? Now, this time, ang tinatanong ay volume. Okay? We are given now the weight. Okay? So, remember the formula of our specific gravity. It is the weight of the substance divided by the weight of an equal volume of water. Okay? As our standard. Okay? So, to be able to calculate the volume, okay, ang gagawin natin is, excuse me, ayan, so what we will do is, basically, we divide the weight of the substance by its specific gravity. Okay? Ayan, so ito naman yung ating ginagamit na formula. Okay? So, the weight of the substance is 100 grams divided by its specific gravity, that is 1.05, okay? And this is equal to 100 divided by 1.05. This is equal to 95.24 um, ml, okay? Yeah, so whenever the weight here is in grams, the unit here is always in milliliters. Ayan. So that's actually the end of the lecture, but that is not yet the end of the coverage of our discussion. Okay? Ayan. So unfortunately, we don't have a class next week. Okay? And for that reason, what I will do is for the next learning modules, and we still have two, but these are really, really simple ones. Okay. These are concentrations, no, methods of expressing concentrations, and ano pa ba yun? I somehow forgot. Reducing and enlarging formulas, which is a topic that is basically an application of ratio and proportion. Okay. What we will do is I will be uploading a video recording of me discussing both learning modules. Okay. Ayan, so the coverage of our midterm examination will begin from significant figures, dimensional analysis, um, including fundamentals, so those are yung some topics in the fundamentals of measurement, including yung pharmaceutical measurement, ayan, including your metric, apothecary, avoidable system, interconversion between units, and also the Aliquot method and um, least weighable quantity method of weighing and measuring. Okay, plus these modules 4, 5, and 6. Okay, so density, specific gravity, and specific volume, plus methods of expressing concentration. Ayan, we will be focusing more on percent strength and ratio strength. I will present to you molarity, normality, and molality, but I will not actually tackle that much yet, okay? Because we have another module that will involve millimoles, milliequivalents as well, okay? Later on in the finals. And then lastly, yung reducing and enlarging formulas. Now, I have decided that the coverage is up to that point because all of these will involve the same for the same calculations. Okay, all of these will involve dimensional analysis and ratio and proportion. Okay, ayan. So I feel naman it is better if we put them here kaysa masyadong marami in the final term. Okay, because in the final term we will have more formulas. Okay, you will have to study more formulas, and I'll even discuss a little bit of inorganic pharmaceutical chemistry for you to get by, okay, to learn about the valences of metals, okay, which we will also tackle in the final term, okay? Ayan, so I will not be holding you any longer, ayan, although I would like to, ayan, kaso I think you have a class ng 12 or 1, no? Ayan, so I have already extended enough, okay? So I will just be posting, okay? Ayan, I will just be posting a video of me discussing calculations involving concentration and reducing and enlarging formulas. Okay? Ayan, so is that okay with you? Ayan, or gusto niyo mag-continue ako hanggang 12? Alam mo na yata kayo. Okay, ayan, sige. I I I think silence means yes, no? Ayan. So